Hi guys, in this video we're going to talk about how to do calculations with a limiting reactant. In our last one we looked at drawing diagrams to show how the particles react and form new particles and what happens when you have leftovers or not enough. And so this time we're going to look at how to do the calculations to figure out how many moles or grams of whatever you have you're going to get and which one is the limiting reactant that way. So let's get out our Cornell paper. Here's mine. The first thing you want to do is fill out this name, date, and class period business, and then our objective will be Objective 4. That's the last one in the homework packet, and that is calculations with limiting reactants. And in order to do this, let's figure out what our essential question is. How do I calculate which substance is the limiting reactant? So that's going to be what we're trying to figure out here. So we'll need an equation and a sample question, but first let's talk about what a limiting reactant is. There's our limiting reactant. So this is whatever you run out of first. So your reaction is going, and you've got two reactants there and they're reacting with each other, but one of them's going to run out before the other one does. And when that happens, the reaction stops. So how do we figure out which one is our limiting reactant, and then what can we do with that information? So let's go ahead and pull up our, our chemical equation that we're going to work with and our sample question. P4 plus 3O2 gives 2 P2O3 is our sample equation. And here's our sample question. 45 grams of P4 react with 40 grams of O2. Which is the limiting reactant, and how many grams of P2O3 form? So you might be looking at this and say, well, clearly I only have 40 grams of the O2 and I have 45 grams of the P4. Since I have less O2, I'll probably run out of that one first. But you have to take into account that there are coefficients in our equation and those substances don't have the same molar mass, so we might not have more of the P4. So let's go ahead and do our calculations. So the first thing that we need to do is we need to figure out how many moles of each of these do we have. I know from my equation that I need 3 times as much moles of oxygen as I have P4 in order to get P2O3. So let's figure out how many moles I have. So that'll be my first step. We'll label it right here. Step 1. So we're going from grams to moles. So I'm going to take my 45 grams of P4 and let's see here, 45 grams of P4, and I'm going to divide by the molar mass of P4, which is on the front page of your homework packet, 123.896 grams per mole. And I'm going to do the same thing for my oxygen, but I'm going to leave a little bit of space just in case I want to do some other math. So then I've got 40 grams of the oxygen, and I'm going to divide that by the molar mass of oxygen, which was 31.998 grams per mole. So my calculator tells me that this is 0.363 moles. And right now I can think in my head, I need 3 times as much as that, so this better be 0.9 something, or maybe even bigger than 1, otherwise I'm running out of oxygen first. So let's figure out what that is. My calculator tells me 40 divided by 31.988 is 1.25 moles. So I do have probably 3 times. So then the next question is, which one will I run out of first? Well, I need to divide these by the coefficient. So that's what I'm going to do next. That's basically the next step in in going from grams to grams anyway. So step 2 will be to divide by the coefficient. So let's write that over here. So for my, P4, I'll do the 0.363, and I'll divide that by 1, which I can do in my head. That's 0.363. And for the oxygen, I'll do 1.25 divided by 3. I get 0.416. So that tells me that I actually have more of the oxygen available for my reaction. So this P4 is my limiting reactant. I'm going to go ahead and circle that. There's my limiting reactant. So to answer the first part of the question, which is the limiting reactant, it's P4. P4 is my limiting reactant, and that is because this number is smaller than this number. So the next thing that I have to do is I have to calculate how many grams of P2O3 will form. So let's move on to the next page. So the nice thing about finding the limiting reactant is that at this point I already know how many moles of P4O3 I have to work with. So I just have to bring that number with me, and it was 0.363. Now the rest of the numbers in my calculator, so I get a good answer, is 207. So that's moles of P4, and I need to figure out how many grams of P2O3. That's my question here now. I know that the P4 was my limiting reactant. I have extra O2. I won't run out of that first. Now I have to figure out how many grams of P2O3 I'm going to get. So I already did the step one where I went from moles to moles. So I'm gonna make a note here. Step one, going from grams to moles, I already did, so I'm going to check that off. So now when I do the gram to gram problem, I need to start at step two, where I go from moles to moles using my coefficients. So I'm going to start by writing down what I have, just like I did in the last problem. So I've got P4, and I want the P2O3, and I have a 1, which you can't see. It would be right, whoops, that's not a highlighter. It would be right here. There's a 3 and there's a 2. I'm using the 1 for the P4, and the number in front of my, forgot to switch back, of my P2O3 is a 2. And I have 0.363207 moles of the P4, and I want to figure out what this is. Hopefully you can see that really all I'm going to be doing is multiplying by 2. So I'll get twice as much of the P2O3. So let me scroll down a little here. Okay. So let's see, if I do my 0.363207 times 2, I get 0.726414 moles of the P2O3. So now I just have the last step, step 3, where I go from this moles back to grams. So I need to look up the molar mass of this P2O3 on the front of my paper. I have 0.726414 moles, and I need to multiply by the molar mass of P2O3, which is 109.945 grams per mole. And my handy calculator tells me that I will get 79.865 and a bunch of other numbers grams of P2O3. Now if I needed to, how convenient, if I needed to do any rounding here, maybe it says to round to 2 decimal places. That means that I'll be keeping all of these numbers here. This 5 tells me that I need to change that 6 to a 7, so my real answer that I would type in would be 879.87. Remember, only the last number changes when you do any rounding. And so there you go. Now if you'd like to see another example or you have questions, make sure you ask. Thanks for watching.